Okay, here we go. Now let's try to graph. It's example 3. What page did I say it was on? 865. Okay, so if you want to look there, you can. Here's the equation. We're going to throw everything at it. Yeah, this seems to be writing much better now. 3 sine of 2/3. Now, so far, what is the 3? It's the amplitude. What does the 2/3 deal with? It deals with period. So in order to find the period, you do what? 360 divided by 2/3, right? We'll do that in a second. But now, here's the stuff that's a little bit different. What did that minus 180 do when I put it next to that? It moved it to the right 180 degrees, exactly. And then this is plus 4, all right? So, again, we know that's what I do. Before I even graph this thing, I look at all these numbers and say, okay, what's this do? Well, this stretches it up a little bit higher, doesn't it? So if a normal sine went like this, then the 3 would make it go up higher, all right? The 2/3 changes the period. So the period's not going to be 360 now. It's going to be, let's do it. So the period is 360 divided by 2/3, which is the same, right, as 360 times 3/2. That goes 180. 180 times 3 is 540. So the period now is 540 degrees. All right, so from our y-axis, our 0, I'm going to stretch it out to 540. All right, and our amplitude, let's just, right here, our amplitude is 3. Our phase shift, let me write all this stuff down since this is the first time we've seen this. Now, you don't have to write this stuff down, but I'm doing it just to teach it. Okay, so this is what? The vertical shift. All right, so that's what's going on here. Are you with me? Yeah, they do. Let me say something about that. I've been, like I told you before, I've already warned you that we use degrees a lot just to kind of make things a little easier. I'm just trying to teach you the basic foundation of graphing these things, okay? And I think if I went to radians like right now, right away, I think that adds just one more level of confusion on top of everything. But I am going to warn you, though, that they do start using radians quite a bit. I've geeked it out a little bit last night, and I went to a bunch of websites where teachers do what I do, basically. They use, programs similar to this, and they put it on YouTube. And I think almost every single person that did it, including Khan himself, uses radians almost every time, okay? I realize I'm using degrees, but be ready. But most of those are like for pre-calc classes. Like I went on a couple teachers, and it's like a pre-calc stuff. So they're teaching you how to do this in a pre-calc class. So be ready for that next year. We'll introduce it every once in a while in here. This is only Algebra 2. But we'll, when you get to pre-calc, they'll probably primarily, instead of saying theta minus 180, what would they say? Theta minus pi. No, not pi over 2. Oh, yeah, just pi, right. Right. So, and a lot of times they don't use theta. Sometimes they'll use an x, which really means the same thing. Yes. I believe so, yes. All right, so let's put an axis right here. Let's put the y-axis about right there. And let's just mark some stuff, okay? The period is 540, so I'm going to come out here. I'm not going to go all the way to the end. You'll see why in a second, but I'm going to go right here and say that's 540, all right? And I like to go split everything in half. So if you go half of that, what is that? It's 270. And if you split half of that, that's 135. Now if you go halfway between here, what is that one?
405.
405, good. Because basically, look, from 0 to 135, each one of these quarters is how much? 135, right? So you just go from 270, go 135, and that's 405. Make sense? Okay. So there we go. So that would be one full period, but we got to see what's going on here. Let's go to the, not even the amplitude, let's go to the vertical shift right here. Let's take a look at that thing. It actually shifts up 4 places, doesn't it? In fact, what I'm going to do, yeah, you know what, I'm just going to scooch this down just a little bit. About right there, because I want to give it some room, because it's going to go up a little higher, because it shifts up. It shifts up 4 places, doesn't it? So watch what I'm going to do. I'm going to go right to the vertical shift and figure out what it does here. Now, let's just say that's 1, 2, 3, 4. Now, what happened? Normally, everything would be, this would be your center line, wouldn't it? Everything would be just as high to this line and just as low to this line. But This is not going to be the center line now, is it? Because we took this thing and we shifted it up how many places? 4 places. So we actually shifted this thing up, so it's going to hit right here. Actually, I'm going to put the 4 right there. Okay? Yeah, exactly. So this is going to be a new midline, isn't it? All right? And I think that's what they call it. I think they call it a midline or center line. There's no perfect way to call it, but we'll call it a midline. Okay? So the middle is going to be right here this time, isn't it? So let's just make it a different color. Let's go red, and I might have to move it around a little bit, but look at that. That's pretty good. So that's going to be your new midline. So if you want to make this a little bit easier, if you want, instead of seeing your angles down here, you could put it right here, couldn't you? I don't know if that makes it any easier for you or not, but I think it might help, because everything's like right there. Now I didn't take the time to see if these are evenly distributed, but they should be. All right, that's good enough. All right, you with me on that? So watch, it's going to go up and it's going to go down to that line right there. Now, what do you think the next thing might be? We talked about the vertical shift. Well, let's talk about the amplitude now, since we're talking about the up and down. So this is the center line, right? So if it just went up 1, if the amplitude was 1, it would just go up to where?
5.
It would just go up to the 5, but it doesn't go up 1, does it? That's right. It goes up to 7. Why? Because you're going to go up. The amplitude is 3. 3 from where? 3 from your center line, your midline. Does that make sense?
Yeah.
So it doesn't just go to the number 3. It goes from the center line. It goes up. Since we shifted it up 4, center line is at 4. So now we're going to go up 3. 1, 2, 3. And where does that put us? It puts us at 7. What about 3 down? It goes 3 down from the center. It's going to be right here at 1, isn't it? All right. We're going to have some junk in there, so I'll put the 1 on that side. Does that make any sense?
Yes.
Okay, so now we've taken care of that. We've taken care of the period, we've taken care of the amplitude, we've taken care of the vertical shift. If that was all there was to it, it would be really easy. In fact, let's do this, just to kind of show the difference between the normal sine and the phase shift. Sometimes the phase shift is the most difficult of all this, okay? Let's go a different color. Let's go a light blue. So this is what it would be if you didn't have the phase shift. Are you with me on this?
Yeah.
So what I'm going to do is I'm going to graph this without the phase shift, because the phase shift is a little bit tough. So it's a sine function. So where is the sine? It's going to go through here, isn't it? So we're going to put a point right here. If you're not sure about it, let's check it out. Again, I'll tell you what, I'll do this in blue. What I'm doing is I'm going to put 2 right on top of each other, basically, side by side, however you want to look at it. And let's just say that's theta, not a theta minus 180. You okay with that? And plus 4. So in blue, same colors, we're going to do this. So if I put a 0 in for theta, well, what's 2/3 times 0? It's 0. What's the sine of 0? There's 0 degrees. What's the sine? It's 0, isn't it? Remember, the ordered pair is 1, 0. You should be able to do that in your head. So the sine is at 0. What's 0 times 3?
0.
What's 0 plus 4?
4.
Right there. That's where it is. Do you see it? All right, so that's our point. Now, what do you think? You don't have to do that for every one of these, but the sine, it comes from this direction. It goes through here. Where do you think it's going to top off at? At 135. Good. So we top it off right there. Where do you think it goes down and hits the 0 again? 270. At 405, what's it going to do? It's going to hit the 1. That's right. And then it's going to hit the 540. That would be without the phase shift. Everybody understand that? All right. I'm going to try to draw it. Oh, man. I dipped a little too early, but you get the idea. All right. And it would keep on going, obviously. You okay with that? What in the world is that phase shift? It's a pretty significant phase shift. I mean, 180 degrees. I mean, you're moving it halfway around the circle, right? So it's definitely significant. What color do you want to go with that? You want to stay black since we wrote that thing in black, or do it in red maybe?
Green.
I tell you what, let's do this. I'm playing around too much. Let me just do this real quick. Let's make this black again. Is that all right? Are we almost out of time? 9:32. Okay. And then let's go. Yeah.
Red.
Let's go red. Yeah, that shows up a little bit better. All right. Yep. Should we? Yeah, we should probably go to the next one, shouldn't we? All right, let's go to the next one.